Then finally something called logic design. This logic design is the core. This is where people will implement the business rules. When I say a business rule, a simple rule, before doing a withdrawal, right, from the ATM machine should run a software that should check whether you have enough money in your account to give out that money from the ATM machine, right? It's a simple logic. Who does this logic? Previously people used to do that logic. Now software is doing that logic. If logic is not done right, your program is going to be working the other way, right? So in software there are a lot of principles like if, then else, then looping, right? Then SQL queries, right? Then variables, right? There are a lot of things through which the logic is implemented, right? File handling, query handling. If the programmer has not done that logic correct, it is going to be a problem. But before even the programmer does all this logic, programmer does all these logic, right, in language. That is the programming language. This will be like C, C++, Java, C#, right, PLSQL, etc. That is very specific to software. But before even the programmer does that logic, write that logic in plain English, right? Again, please refer to our software design webinar. It will give a lot more insight about what is logic design. This is a time consuming job, and this is done by senior people, typically called systems analyst. Systems analysts are the ones who are experienced programmers. Maybe even after 5-6 years or even 8 years, you gain experience, then you can straight away think in English to find the logic, write it down in English or any natural language that your team can understand. If your team contains all French people, write it in French. If your team contains all Japanese people, write the logic in Japanese. No harm. Write it so that they can convert that language to programming language. This is also known as algorithm. This is also known as pseudo code. A code is in the programming language, a pseudo code is in the natural language, right? So writing all these four, right, is called a design. Again, within logic design, if you further break down, there is something called class design for object oriented languages. Then there is something called sequence diagrams, right? What action has to happen before some action? After this action, what should happen? What is the timeline sequence of operations? Then how one class interacts with another. This is called class interaction diagrams. But all these things are a manifestation of the logic design and interface design. So based on all these things, a programmer should be in a position to draw the screen or to write the database creation scripts or the program. Typically people use different two major approaches called top-down design approach. This means take a bigger problem, okay, then break it down to small pieces, okay. So don't take a bigger problem at a chunk. Take a bigger problem, slice it, then design the smaller slices, which will be easy. Typically it's called a top-down approach. There is another approach called bottom-up approach. In this, many low-level operations are already defined. For example, in today's world, if I want to know a shopping cart, if I want to integrate a shopping cart program into my online shopping application, or a PayPal or a payment gateway integration, I do not have to code. These are already available. When many pieces are already available, and if you know they are ready, you need to know how to build using those bricks, right? They are the building blocks, right? Use these blocks to build the application. That's called a bottom-up approach. Again, it's not a hard and fast rule I should use this approach or that approach. Whichever is easy for you, you can use that approach. No hard and fast rule. But typically, if the pieces are already available in one or the other way, use bottom-up approach. If the pieces are not available and you are developing a brand new app, then better use top-down approach, right? A typical way of approaching any problem is, right from our childhood we have been learning, like take a bigger problem, narrow it down. So that's a top-down approach, always applicable in most of the places. So this is called a design. Okay. This design will also have another area called architecture. Okay. I didn't touch this architecture, the word architecture, at the beginning of the design because it may slightly confuse you. But now you know the building blocks of design. Architecture meaning how your application, okay, will look in terms of hardware and in terms of software pieces. Okay. For example, hardware architecture, right? I may say our application needs a firewall and then a web server within that, then an application server that is connected to a database server, right? So typically I am having 3 different machines and a firewall before I connect to the internet for my application. Probably you can go to some of the search engines and then look for architecture diagrams. We will also upload some of the architecture diagrams in our website. So how physically it will look, that's called the physical architecture. Then software architecture, meaning how logically, okay, the programs are grouped and deployed, in which server, what class files, what configuration files, what web pages are deployed, and how they are integrating with each other. That's called software architecture. Of course, to some extent the hardware architecture will have an impact on the software architecture also, but typically in today's context we are all using something called the N-tier, right? N-tier architecture. That means the software has been divided into many slices or many logical groups. Each of these groups are deployed in a different machine, and they interact with each other through interfaces. That's called architecture. This architecture happens before the design starts. Okay. This architecture is done before design, right? Because architecture is at a very top level and design is at the next level. So this is about software design. This is another phase after the requirements phase. Okay.